Good afternoon, students. Good afternoon to everyone. Today we shall continue our discussion on aldehydes, ketones, and carboxylic acid. Dear students, in last class we discussed about the preparation of benzaldehyde. The three important named preparation we studied is: one is Rosenmud reduction. See, in Rosenmud reduction, benzoyl chloride C6H5COCl is reduced in presence of palladium with barium sulfate as a catalyst, and we will obtain benzaldehyde. And that particular reaction is called Rosenmud reduction. And again we studied Stephen's reduction. In Stephen's reduction, the basic organic compound is nitrile, and we will obtain aldehydes. See, what are Stephen's reagent? Stannous chloride and hydrochloric acid. Stannous chloride and hydrochloric acid. On reduction, an intermediate imine is formed. CH double bond NH, which is nothing but imine. And again on acid hydrolysis, you will get aldehyde. That is called Stephen's reduction. Are you clear? Next, we studied Itard reaction. See, oxidation of toluene by using chromyl chloride to form an intermediate compound, and again finally on acid hydrolysis we will get an aldehyde, that is benzaldehyde. That is Itard reaction. See, Itard reaction is also carried in presence of chromic oxide and acetic anhydride. Again, see, toluene, when it is treated with chromic acid and acetic anhydride, an intermediate is formed. That intermediate on acid hydrolysis gives benzaldehyde. Are you clear? So these important reactions we go through. And we wrote the chemical reaction also, Rosenmud reduction. Are you clear? So we shall continue our study on preparation of benzaldehyde, that is halogenation. Halogenation. See, toluene, which is a derivative of benzene, toluene, CH3. See, when it is chlorinated in presence of diffused sunlight, so we'll get benzyl chloride. See, CH2Cl2. Are you clear? So this again on acid hydrolysis, so benzaldehyde is obtained. Are you clear? So this is nothing but a simple halogenation we can find. Again, a derivative of benzene, that is nothing but a benzene only. When benzene is treated with carbon monoxide with HCl, along with HCl, hydrochloric acid. See, it is benzene acid. See, it is benzene is treated with carbon monoxide and hydrochloric acid in the presence of anhydrous AlCl3 or CuCl, cuprous chloride. Benzaldehyde is obtained. See, benzaldehyde is obtained. CH4 benzaldehyde is obtained. A very simple reaction, benzene. See, and this particular reaction, very important reaction, and it is called Gattermann-Koch reaction. Gattermann-Koch reaction. Are you clear? In Gattermann-Koch reaction, are you clear? In Gattermann-Koch reaction, benzene is treated with carbon monoxide and hydrochloric acid. In presence of anhydrous aluminium chloride or cuprous chloride as a substitute reagent, and it is oxidized to get benzaldehyde. Are you clear? And it is called Gattermann-Koch reaction. It's called Gattermann-Koch reaction. Always we will get 2 marks question. How benzaldehyde is prepared from benzene, and name the reaction. Benzaldehyde can be obtained by benzene on treating it with carbon monoxide along with hydrochloric acid in the presence of anhydrous aluminium chloride or cuprous chloride. It forms benzaldehyde. A benzaldehyde is obtained, and this particular reaction is called Gattermann-Koch reaction. Are you clear? It's called Gattermann-Koch reaction. Are you clear? See, very simple reaction. Benzene treated with carbon monoxide and hydrochloric acid in presence of anhydrous aluminium chloride or cuprous chloride, benzaldehyde is obtained. See, no need to write any intermediate step. Very easily, directly you have to write the reaction. Are you clear? Okay, that is called Gattermann-Koch reaction. The named reaction in the preparation of benzaldehyde is Rosenmund reduction, Stephan reduction, then Ittard reaction, and Gattermann-Koch reaction. These are oxidation reaction. Stephan and Rosen are reduction reaction. Are you clear? Okay, we shall continue our discussion on, say, preparation of benzaldehyde is completed. Then we shall go on preparation of ketones. Preparation of ketones. See, ketones can be prepared. Ketones can be prepared by different methods. We shall study one by one. So we discussed Gattermann-Koch reaction, benzene, carbon monoxide, and hydrochloric acid. So in preparation of ketones, say preparation of ketones. In ketones, say this is nothing but R2R C double bond O Cl. See, acyl chloride, which is from acyl chloride. When this is treated with cadmium chloride, CaCl2, cadmium chloride. So we will get, say, R2CD, which is nothing but cadmium chloride. Okay. In presence of, say, magnesium bromide, cadmium chloride, and we will get here 2R MgBr, which is nothing but a magnesium bromide, and we got here R2C plus, and we got, say, here Mg 2MgBrCl2. It is 2 alkyl group with Grignard reagent. RMgBr, Grignard reagent, not acyl chloride. First you have to prepare, say, dialkyl cadmium, and it is called dialkyl cadmium. Are you clear? See, 2 alkyl groups are there. It is nothing but a Grignard reagent. Grignard reagent. Grignard reagent. So when this Grignard reagent is treated with cadmium chloride, dialkyl 2 dialkyl cadmium is obtained. See, this one treating with acyl chloride. So acyl chloride. So therefore, see R C double bond O Cl, which is in 2 molecules, then plus R2 CD, and we will get say 2 R C double bond O and R dash plus we will get cadmium chloride CdCl2. So this is nothing but ketone. Are you clear? It is nothing but ketone. So ketone is prepared from acyl chloride or acyl chloride. Are you clear? See RC double bond OCl. Particularly we can also prepare. See 2CH3 C double bond OCl. So in presence of CH3 twice cadmium. So we will get here dialkyl cadmium, and we will get 2CH3 C double bond O CH3 plus CdCl2. So this is nothing but acetone, which is nothing but a ketone. Thus, we can easily prepare ketone from acyl chloride. So this is acetyl chloride, CH3COCl. When it is treated with the dialkyl cadmium, how dialkyl cadmiums are obtained? When cadmium chloride is treated with Grignard reagent. When they are treated with Grignard reagent, we will get dialkyl cadmium. When dialkyl cadmium, here particularly methyl cadmium, it is treated with acyl chloride, we will get acetone. A very simple preparation. And this particular preparation is called, say, from acyl chloride we can obtain ketone. So what you have to remember? First you have to take the Grignard reagent. It should be treated with cadmium chloride to form dialkyl cadmium. Dialkyl cadmium, on treating with acyl chloride, ketones are formed. A particular reaction, if you go for a particular reaction, say CH3 C double bond OCl, then CH3 twice Cd, we will get 2CH3 C double bond OCH3 acetone, which is nothing but propanone. What is side base name? Propanone. No. And cadmium chlorides are formed. That's all. A very important preparation of ketone. Okay, we shall study. I will repeat again. See, ketones are prepared by acyl chloride. First, dialkyl cadmium is prepared by treating cadmium chloride to Grignard reagent. The required dialkyl cadmium is prepared by treating Grignard reagent with cadmium chloride to form dialkyl cadmium. Dialkyl cadmium reacts with acyl chloride to form ketone. Particularly, acetyl chloride reacts with dimethyl cadmium to form acetone or propanone. Are you clear? A very simple reaction. You can easily remember. Okay, next we have to continue our discussion on preparation of phenol. from nitrite, from nitrite. We shall prepare ketones from nitrite. See, when the nitrite, you know the functional group nitrite, which is Cn, So this is a nitrite. See, CH3, CH2, Cn, which is nothing but nitrite. It is nitrite. So when this nitrite is treated with, see, phenyl magnesium bromide, which is nothing but C6H5MgBr. See, it is heated in the presence of ether. We have, see, nitrite. The base compound is nitrite, and phenyl magnesium bromide. Phenyl magnesium bromide in the presence of ether. So we will get, say, CH3, CH2, C. It has a double bond with nitrogen and again with C6H5. And here magnesium and chlorine. It bridges Br. So which is an intermediate spot. See, very simple reaction. Nitrite reacts with phenyl magnesium bromide in the presence of an ether. So we will get an intermediate product. So this intermediate product on acid hydrolysis. So we will get say CH3, CH2, then C double bond O, and C6H5. Are you clear? See, which is nothing but propiophenol. It is nothing 1, 2, 3 propiophenol. We will get propiophenol. One propiophenol. Are you clear? So it is nothing but a ketone. See, again, ketone can also be prepared by benzene. When benzene or substituted benzene is treated with acetyl chloride, say CH3, CO, Cl, in the presence of anhydrous aluminum chloride. So if it is anhydrous aluminum chloride, it is nothing but Friedel-Crafts alkylation. So we will get acetophenol. C double bond O, CH3. Are you clear? Very simple. Plus HCl. So this is how a ketone can be prepared. So ketone can be prepared by three important methods. The first method is from acyl chloride. Second one is from nitrite. And third one is from benzene. We will get acetophenol. Are you clear? See, only three methods are there for the preparation of ketones. Ketone can be prepared by nitrite. When the nitrites are treated with phenyl magnesium bromide in the presence of an ether, an intermediate is formed. See, this intermediate on acid hydrolysis, it will give a ketone. So propiophenol, a benzene ring is there. Again, acetophenol, C6H5UCOCH3. It is obtained by treating benzene with acetyl chloride in the presence of anhydrous aluminum chloride. If a reagent anhydrous aluminum chloride is used, and it is called Friedel-Crafts reaction. It is Friedel-Crafts reaction. Are you clear? In Friedel-Crafts reaction, we have benzene is treated with methyl. See, it is nothing but acetyl chloride, not methyl, acetyl chloride. In the presence of anhydrous aluminum chloride, acetophenone is obtained. It is a ketone. It's a ketone. And this is a very important method for the preparation of ketone. Are you clear? We completed the ketone can be prepared by dialkyl cadmium, and it can also be prepared by nitrile, and it can also be prepared by benzene and acetyl chloride. Are you clear? So this completes our study of preparation of ketones. Preparation of ketones, and we shall study some part of next your syllabus. So that is physical properties of aldehydes. Physical properties. Physical properties. Properties of aldehydes and ketones. Physical properties of aldehydes and ketones. So what are the important physical properties of aldehydes and ketones? First, go for solubility, boiling point. These are very important physical properties. See, in physical properties, if you compare the boiling point of hydrocarbon and as well as hydrocarbon and as well as haloalkanes. See, it is due to dipole-dipole interaction in aldehydes and ketones. There must be a weak dipole-dipole interaction is there in aldehydes and ketones. Therefore, boiling point of aldehydes and ketones are more than that of similar molecular mass hydrocarbons and alkyl halides and as well as ether. Are you clear? See, hydrocarbons, then haloalkanes, and ethers. They have less boiling point than aldehydes and ketones. Understood? Which one? Boiling point. See, it is due to dipole-dipole interaction. Dipole-dipole interaction. Very important point you have to remember. Sometimes we will ask for 1 mark. Why? The boiling point of aldehydes and ketones are more than that of similar molecular mass hydrocarbon or haloalkane or ether. It is due to dipole-dipole interaction you have to write. Are you clear? 1 more question. Why aldehydes ketone shows higher boiling point than similar molecular mass hydrocarbon or haloalkane or ether? See, it is due to dipole-dipole interaction. I think you understood the point. Okay, then we shall continue our study on. See, we compare boiling point. We'll complete the boiling point of alcohol and aldehydes and ketones. Can you tell? See, alcohol shows higher boiling point than aldehydes and ketones due to the presence of intermolecular hydrogen bond in alcohols. Are you clear? See, alcohol shows more boiling point, more, and here it is less. See, it is due to intermolecular hydrogen bond. Intermolecular hydrogen bond. So therefore, alcohol shows higher boiling point than aldehydes and ketones of similar molecular mass. Are you clear? Understood? Okay, if alkyl branches are more in aldehydes and ketones, see automatically its boiling point is less. And here alcohol shows more boiling point than aldehydes and ketones. Somewhere you will get one more question. Okay, we shall go for solubility. See, among solubility, you can find in the solubility these lower aldehydes and ketones like methanol, acetone, ethanol. All these are miscible with water. Because the oxygen atom which is present in aldehydes and ketones, it will form hydrogen bond with water molecule. They are miscible. But higher molecular mass aldehydes and ketones, they are immiscible with water, but they are soluble in organic solvents. Okay, that is nothing but the solubility. So you can compare in physical properties, particularly the boiling point and the solubility. So boiling point of aldehydes and ketones are more due to dipole-dipole interaction. But as you compare alcohol and aldehyde and ketone, alcohol shows higher boiling point than aldehydes and ketones due to intermolecular hydrogen bond. Are you clear? This completes our study of physical properties of aldehydes and ketones. Are you clear? Physical properties of aldehydes and ketones. In physical properties, say aldehydes and ketones shows more boiling point than hydrocarbons, haloalkane and ether. Repeatedly I am explaining. Same thing, nothing else. Alcohol shows higher boiling point than aldehyde and ketone due to intermolecular hydrogen bond. And here solubility of this is more. So this completes our study of physical properties of aldehydes and ketones. Physical properties of aldehydes and ketones. Then we shall move on to chemical properties. Chemical properties of aldehydes and ketones. Are you clear? See, this is nothing but a carbonyl compound or C double bond O H, which is an aldehyde. Are you clear? Or CHO. What is the functional group? CHO. See, here we can find a resonance. Now, this will become negatively charged. C negatively charged, and this will become partial positive charge and H. So we can find a resonance. See, this is electron deficient center and this is electron rich center. An electrophile can attack here. A nucleophile can attack here. So we can find in aldehydes and ketones, a nucleophilic and as well as electrophilic substitution reaction. So that is the characteristics of aldehydes and ketones. Say, be familiar this reaction. Say, as carbon to oxygen, here whatever carbon it is nothing but sp2 hybridized. And this sp2 hybridized, we can find 1, 2, 3. How many? Sigma bonds. And pi bonds, we can find pi bonds. Say 1 pi bond we can find. So this resonance chemistry is electron deficient center and this is electron rich center. Again, yeah, it can also be possible reversibility, and you will get R, C double bond O and H, and this is aldehyde. See, in original position you can find. So therefore, electrophilic as well as nucleophilic substitution reaction takes place in aldehydes. We shall study those reactions one by one, and you have to study their mechanism. We shall continue our discussion in the next class. Are you clear? So we discussed some physical properties and the basic introduction of the chemical properties. And aldehyde, how a resonance takes place. Okay, thank you. We shall continue our discussion tomorrow.